9 is replaced by this. 2 times 10 to the 9 times 1 minus Vs over 3 times 10 to the 8 all over 1 plus Vs divided by V. V is 3 times 10 to the 8. Now, I'm sure some of you will get intimidated by seeing these figures. Now, is it possible that we can solve this equation now for Vs? You can see Vs is the only unknown quantity in that equation. So all we need to do is persevere and simplify. Let's do that. Alright, left hand side, let us leave it like that. Right hand side over here, see what I did? I took 3 times 10 to the 8 common factor, and the numerator now becomes 3 times 10 to the 8 minus Vs all over 3 times 10 to the 8. That's okay? This is simplified by taking the common denominator. Similarly, 1 plus Vs over 3 times 10 to the 8. 3 times 10 to the 8 is the common denominator. So that will be 3 times 10 to the 8 plus Vs all over 3 times 10 to the 8. And if you notice now, this 3 times 10 to the 8 will cancel with that 3 times 10 to the 8, leaving us on the numerator 2 times 10 to the 9 times 3 times 10 to the 8 minus Vs over this quantity. There you are. I just gave you those. These two are cancelled. On the numerator you have 2 times 10 to the 9 times 3 times 10 to the 8 minus Vs. And on the denominator we have this quantity. There we are. Okay, what do we now do? Our left hand side is, you can see, I'm going to divide both sides by 2 times 10 to the 9. You see, when I divide both sides, the left hand side becomes, this is the left hand side. Divide that by 2 times 10 to the 9. When you divide the right side by 2 times 10 to the 9, they will cancel. The right side now becomes 3 times 10 to the 8 minus Vs over 3 times 10 to the 8 plus Vs. Okay, you can see the steps that we are taking. I'm going to now leave it for you to solve that. This is now simple to solve. Vs is the only unknown. I solved it. I got 22 meters per second. I tell you, most of you have graphing calculators which will solve equations like this. If you have difficulty solving it on your own, put it on the calculator. It will solve it for you. Okay, that is a challenging problem. Let's try another one. A physics student walks down a long hall carrying a vibrating 512 Hz tuning fork. The end of the hall is closed so that the sound reflects from it. So as the student walks down the hall, the sound gets reflected from the wall in front and is received by the student. Now, the student hears a sound of 516 Hz from the wall. Alright? Now, how fast is the student walking? Well, this again is a similar problem, but its complexity is not as much as the one we did earlier. The actual frequency of the source, the frequency of the tuning fork, is 512 Hz. The speed of sound, this time it is sound, speed of sound is 340 meters per second. F double prime is 516 Hz. What does that mean? You see, this again you need to break it into 2 stages. The first is, there is a source that is moving towards a stationary listener. Who is that stationary listener? The wall. The wall in its turn, in stage 2, the wall reflects that sound back to the student. Now in the second stage, The wall is the stationary source and the student is the listener who is moving towards that source. And the frequency as is heard by the student is 516 Hertz. That is F double prime. Okay. Vs is the speed of the student. So here again, this problem has two parts. What is the first part? In the first part, the student is a moving source and wall is the stationary listener. Now, what is the equation for the frequency as is received by a stationary listener when the source moves towards it? Can you recall that formula? The frequency f prime received by the wall is f prime equal to f0 divided by 1 minus Vs over V, where you know f0, we know Vs, we know V, the speed of sound, we don't know Vs. Alright, that will be 512 divided by 1 minus Vs over 340. Is that right? f0 divided by 1 minus Vs over V. That is the frequency as is heard by the wall. Now, in the second part, the wall is the source which emits this frequency f prime. This is the frequency received by the wall which is reflected back to the listener. So this f prime is now the frequency that is emitted by a stationary source and the student is the listener. We have the case where the listener is moving towards a stationary source. What is the frequency that is received by a listener moving towards a stationary source? If f prime is the frequency heard by that listener, then f double prime, not f prime, f double prime equal to f prime times, what does f prime stands for? The frequency that is emitted by the wall, which is actually this. So f double prime equal to f prime times 1 plus Vs over V. Well, that is f prime times 1 plus Vs over 340. Alright? We can now replace f prime by this quantity, and f double prime we know. F double prime is given to us. So we will do that in the next slide. Look at again, what are the things that we know? We know f0, we know V, we know f double prime, and we know f prime equal to 512 over 1 minus Vs over 340. And this is the equation we have now. F double prime equal to f prime times 1 plus Vs over 340. What do we do now? We know our f double prime and we know f prime is that relation which we're going to replace there. So 516 equal to, this f prime is replaced by this quantity, 512 divided by 1 minus Vs over 340 times this 1 plus Vs over 340. Alright, can you help me now solve for Vs? Vs is the only unknown quantity there. Alright, what I can do now is, that will be this quantity equal to, that will be this, I'm going to simplify the right hand side. That will be 512 over, look at the way I simplified this denominator. Took 340 as the common denominator, and that becomes 340 minus Vs over 340. That is this quantity. So this now becomes 512 divided by 340 minus Vs over 340 multiplied by Again, this is simplified by taking 340 as the common denominator. That becomes 340 plus Vs all over 340. That is this one. Okay, can you simplify this? Where does this 340 belong to? You see, a number divided by a fraction. This will now go to the numerator. And when this goes to the numerator, that will cancel with this 340. So actually, this 340 will cancel with that 340. So what is left here is 512 times 340 times Vs on the numerator, and the denominator is 340 minus Vs. I hope you understand that. This 340 will cancel with that 340. So my numerator now is 512 times this quantity, and the denominator is this now. Okay, now what I'm going to do is I'm going to cross multiply. This denominator is multiplied by the numerator. You see, this quantity is equal to 516. So 516 multiplied by 340 minus Vs equal to 512 times 340 times Vs. Do you understand that? Let me just write that step for you. You see, this is actually 516 equal to 512 times 340 plus Vs over 340 minus Vs. What I did is just to cross multiply. So this step is 516 times this quantity equal to that quantity. And now we distribute and simplify. I have done these steps for you. Distribute 516 times 340 is this big number, minus 516 Vs equal to 512 times 340, this big number, plus 512 Vs. Well, this is now elementary algebra. Combine terms in Vs on the right side and the numbers on the left side, and that gives me 1360 equal to 1028 Vs, or Vs equal to 1.32 meter per second. Now, it has been a very good problem. I love this problem. Okay, I want you to go through this one more time and try and do this on your own. Well, I think we have a fair description of Doppler effect and how that can be used in solving problems. Alright, I'm going to stop this lesson here, and there is one more lesson left in Unit 1, and I will get back to you with that lesson a little later. Alright.